Everyone in the Formula One paddock thought they understood the Red Bull RB22 after Australia. They thought they knew its speed. They thought they knew its weaknesses. They thought they knew exactly where Red Bull stood in this new season. But just hours before the Chinese Grand Prix begins, something massive has quietly emerged from inside the Red Bull garage, and it could completely change the balance of power on the grid. Because while the rest of the teams were still analyzing data from Melbourne, Red Bull was already preparing a series of radical adjustments to the RB22. Changes aimed directly at the two biggest threats that appeared in the season opener: explosive reliability concerns, and a tire degradation problem that could destroy race pace over long stints. Now the championship arrives in Shanghai, one of the most punishing circuits for both tires and power units, with a back straight that brutally exposes engine performance and a first sector that punishes front tire balance more than almost any corner sequence on the calendar. Which means one thing: if Red Bull solved these problems, even partially, the RB22 could suddenly look like a completely different machine. And the timing could not be more dramatic. Because in just a few hours, the lights will go out for the Chinese Grand Prix. And the car that rolls onto that grid might not be the same Red Bull we saw in Australia. So before the race begins, subscribe to the channel, because what Red Bull has quietly revealed about the RB22 might be the first real turning point of the entire season. Right after the Australian Grand Prix ended, Red Bull engineers did something very unusual. They did not celebrate the raw speed the RB22 had just shown. They went straight into emergency analysis mode. Because behind the impressive pace that Max Verstappen managed to extract from the car, the data revealed two signals that immediately triggered concern inside the team. The first signal was violent. Impossible to ignore. The power unit failure that shook the paddock. When Isaac Hadjar's engine exploded, it was not just another reliability incident. Inside the Red Bull and Ford engineering departments, alarms immediately went off. The new Red Bull Ford partnership represents one of the most ambitious technical collaborations in modern Formula One. But ambition always carries risk. A brand new engine philosophy. A completely different approach to energy deployment. And a cooling architecture that pushes the limits of packaging inside the RB22. All of it designed to extract every possible fraction of performance. But when you compress technology that aggressively, temperatures become the enemy. And Shanghai is exactly the kind of circuit that can expose that weakness. Because the Chinese Grand Prix is brutal on power units. The long back straight forces engines to remain at full throttle for an extended period, stressing not only the combustion system but also the hybrid components. Energy recovery, battery deployment, turbo temperatures, everything is pushed into a narrow performance window. If the cooling system is even slightly unstable, the consequences appear quickly. Which is why, in the days between Australia and China, Red Bull engineers quietly focused on something that fans rarely see: thermal management. Tiny changes in cooling outlets. Subtle adjustments in airflow paths around the engine cover. Refinements designed to stabilize temperatures without sacrificing aerodynamic efficiency. But just as the team began digging deeper into the engine data, a second problem started to appear. And this one might be even more dangerous for the championship fight: tire degradation. During long-run simulations from Melbourne, Red Bull noticed that the rear tires were entering their thermal limit slightly earlier than expected. Not enough to destroy performance immediately, but enough to shrink the optimal race strategy window. And Shanghai punishes rear tires in a very specific way: heavy traction zones, slow corner exits, and one particular section that every driver fears when it comes to tire wear: the famous spiral opening corner. Drivers enter that corner at speed, then the radius tightens again, and again, and again. The front tires are loaded continuously, and the moment the balance shifts even slightly, the rear tires begin overheating as the driver tries to regain traction on exit. If a car cannot control its tire temperatures there, the damage spreads across the entire lap. Which suddenly made the Chinese Grand Prix something much more important than just the second race of the season. For Red Bull, it became the first real stress test of the RB22 concept. Because hidden inside this car is one of the most aggressive aerodynamic philosophies the team has ever attempted. The floor edges are extremely sensitive. The airflow around the side pods is tightly controlled. And the active aerodynamic system constantly shifts the car between high downforce cornering modes and lower drag configurations for straight line speed. When it works perfectly, the performance is incredible. But when the balance moves outside that narrow window, tire temperature spike, energy deployment becomes inconsistent, and the driver begins fighting the car instead of controlling it. Which brings us to the most intriguing part of the story. Because the adjustments Red Bull brought to China are not meant to make the RB22 faster. Not yet. They are meant to make the car predictable. And in Formula One, predictability is often the real difference between a fast car and a championship car. But what the team discovered during those emergency engineering meetings after Australia revealed something even more surprising. Something that could explain why Red Bull rushed these changes before Shanghai, and why several rival teams suddenly started paying very close attention to what was happening inside the Red Bull garage. But during those internal engineering meetings after Australia, Red Bull discovered something that completely changed how they approached the Chinese Grand Prix. Because the RB22 was not simply suffering from reliability stress or tire degradation. Those were only symptoms. The real issue was hidden much deeper in the behavior of the car itself. And it only appeared under very specific conditions. When Red Bull analyzed the telemetry from Verstappen's fastest laps in Melbourne, the data revealed something fascinating. In certain corners, the RB22 was generating enormous aerodynamic load, even more than expected from the wind tunnel predictions. At first, that sounds like incredible news. More downforce usually means more grip. More grip usually means more speed. But the reality is more complicated. Because the moment that extra load appeared, the aerodynamic balance of the car shifted slightly toward the rear. That shift forced the front tires to work harder to maintain direction through medium-speed corners. And when the front tires begin sliding, even slightly, the driver instinctively corrects the steering on exit. That small correction transfers stress directly to the rear tires. Which is exactly where the temperature spike begins. It is a chain reaction. A tiny aerodynamic imbalance leads to front tire stress. Front tire stress leads to steering correction. Steering correction overheats the rear tires. And once the rear tires cross that thermal threshold, the entire car becomes unstable over a race distance. Now imagine that behavior happening at the Shanghai circuit. A track that repeatedly forces the car into long sustained corners where aerodynamic balance must remain perfectly stable for several seconds. That is why the Red Bull engineers did not arrive in China with a flashy new upgrade package. They arrived with something far more important. Data-driven adjustments designed to stabilize the entire aerodynamic platform. The floor edges were slightly modified to manage airflow sensitivity. Cooling geometry around the engine cover was adjusted to stabilize internal temperatures during long full throttle sections. And most importantly, the calibration of the active aerodynamic system was refined. Because the RB22 constantly shifts between two aerodynamic personalities. High downforce mode through corners. Low drag mode on the straights. Those transitions happen in fractions of a second, and when they are perfectly synchronized, the car feels effortless to drive. But if the timing is even slightly off, the balance of the car changes right when the driver is pushing hardest. And Shanghai's massive back straight makes that transition one of the most critical moments of the entire lap. Drivers exit the long tightening first corner, accelerate through the early sector, and then launch onto that enormous straight where every team deploys maximum hybrid energy. At that moment the RB22 must transform from a cornering machine into a low-drag missile. If that transformation is unstable, the rear tires suffer immediately. Which means that what Red Bull is really testing this weekend goes far beyond simple upgrades. They are testing the core identity of the RB22. Is this car a stable aerodynamic platform capable of dominating long races? Or is it a knife-edge machine that delivers incredible speed but demands constant precision to avoid overheating tires and stressing the power unit? And the answer to that question might determine something even bigger. Because several teams inside the paddock have already started whispering about the true potential of this car. Not its current pace. Its hidden pace. The performance that could appear the moment Red Bull fully understands how to control the RB22. And that possibility is exactly why rival engineers have been quietly watching every run Red Bull completes in Shanghai. Because if the team finds the correct balance here, the rest of the grid might suddenly realize something very uncomfortable about the car they thought they already understood. And that is where the story becomes even more fascinating, because Shanghai is not just another race on the calendar. For engineers, this circuit behaves like a truth detector. It exposes weaknesses that other tracks can hide. And that is exactly why Red Bull's behavior inside the paddock has drawn so much attention over the last few hours. Because several rival engineers noticed something unusual during the preparation sessions. Red Bull was not chasing outright lap time. They were chasing stability. Long runs. Constant setup adjustments. Repeated aerodynamic calibration tests. It looked less like a team preparing for a single race, and more like a team trying to unlock the real operating window of a machine that is still hiding part of its potential. And when you look closely at the design philosophy of the RB22, that approach suddenly makes perfect sense. This car was never designed to be conservative. It was designed to dominate. The aerodynamic surfaces around the floor are incredibly aggressive. The sidepod architecture pushes airflow in very tight channels toward the rear of the car. And the interaction between the floor and the diffuser is designed to generate massive ground effect load when the ride height sits inside a very narrow window. When that window is perfect, the car produces extraordinary grip. But when it moves even slightly outside that range, the airflow underneath the floor becomes unstable. And when that happens, the driver feels something very specific. The car becomes nervous in the middle of the corner. Not completely uncontrollable, but unpredictable enough to force the driver to adjust the steering, the throttle, even the brake release. Those tiny corrections might seem insignificant, but over a full race distance, they change everything. Because every small correction increases tire temperature. Every small correction increases mechanical stress. And every small correction slowly pushes the car away from its optimal performance window. This is why Max Verstappen's feedback has become absolutely critical to the development of the RB22. Verstappen is one of the few drivers capable of feeling microscopic changes in aerodynamic balance. He can sense when the front end begins losing load by just a fraction. And during the analysis after Australia, his feedback revealed something extremely important. The car was not losing performance everywhere. Only in very specific phases of the corner. Entry felt sharp. Initial rotation felt strong. But the moment the car approached the middle of longer corners, the balance shifted slightly toward the rear. That is exactly the moment when front tire load increases, steering corrections appear, and the rear tires begin their slow climb toward overheating. Now think about what that means for the Chinese Grand Prix. Shanghai contains multiple long-duration corners where the driver must maintain steering input for several seconds. If the aerodynamic platform shifts during those moments, the tire degradation problem multiplies. Which is why Red Bull engineers focus their efforts on something that most fans never even notice. Aerodynamic stability across sustained cornering phases. Tiny adjustments in the floor edges. Refined airflow control around the rear suspension. Calibration changes in how the active aero transitions behave under heavy acceleration. Each of these changes on its own may seem small, but together they aim to solve a much bigger question. Can the RB22 remain aerodynamically stable when the car moves through different phases of a lap? Corner entry, mid-corner load, corner exit, and then the sudden transformation into a low-drag configuration for the enormous Shanghai Straight. Because if that transformation becomes smooth, something very dangerous could happen for the rest of the grid. The tire degradation disappears. The power unit temperatures stabilize. And suddenly the full aerodynamic potential of the RB22 can finally be used without compromise. Which leads to the question that several rival teams are quietly asking themselves right now. What happens if Red Bull solves this problem tonight, just hours before the lights go out in Shanghai? Because if that solution exists inside the data Red Bull has been collecting this weekend, then the car that lines up on the grid for the Chinese Grand Prix might reveal something the rest of the paddock has been hoping not to see this early in the season.